ideally, I think the two of you guys are sort of, yes, up here the whole time.
Where are you going to be?
And I'll be wherever I have to be to make the slides go.
Hey, sound check. Temiz değil mi? Tamam.
since this conversation is likely to be a relatively intimate one, and we are hoping to spend half the time on your questions and answers, would people mind coming up to the table? Join us up here, please. Not to compel you if you want to duck out the back, but if you are willing to join us up here, it will be that much more convivial. Yes, I believe there's power underneath the tables there, and so I think we'll get started. And if people come in a few minutes afterwards, you know, they'll catch up. And I think this session has always been a very informal one. We try and take the first half with slides to move very quickly and try and drop a lot of terms on you. The slides will all, of course, be available online afterwards for your reference. And most importantly, all of us will be available to you by email or catch us in the hallways, and we can answer questions throughout the rest of the week. So I do not... Oh, yeah. I just will get to introductions here in a moment. Rohan Samarajiva, I found out late last night that his flight was arriving here at 6 a.m. So he will not be joining us, I think, or he'll show up a little later. So to begin with introductions, to my left, your right, Audrey Planck, Director of Cybersecurity and Internet Governance at Intel Corporation. And to her left, your right, Nishal Govardhan, who works with me at Packet Clearinghouse, based in Johannesburg. He ran the technical operations for Afrinic before that. The internet is, oh, sorry, and I'm Bill Woodcock, also with Packet Clearinghouse. I'm the executive director. So the internet is often depicted as a cloud, which is, of course, an abstraction. It is an idea that represents a lot of complexity without having to go into the details. We're going to try and take you into the details a little bit. So specifically, the internet is a whole lot of separate networks that are all interconnected in a sparse mesh. That means every network does not have to connect directly to every other network in order to pass messages. You can get messages from anywhere on the internet to anywhere else on the internet indirectly through other networks, transiting other networks. So we're going to use this convention here where we have definitions for terms. A little dictionary will pop up. The distinction here is between internet with a capital I and internet with a lowercase I. This is the distinction between the internet, which is the network of all networks that use the internet protocol. It's the sum of all of them, versus an internet, which is just a network of connected machines or networks that doesn't necessarily use the internet protocol. So with that, I will move over to Nishal. Yeah.
Good morning, everybody, and welcome to IGF 2014. So Bill's very kindly asked me to help out with the panel on how the internet works, and he hasn't given me a lot of speaking time, so I'm going to go through at least the presentation quite quickly, and hopefully we'll have time to do a lot more questions later on. So we already have a paradigm for finding information. If you think about using the telephone systems that you do today, you have a mechanism where you have a name, and attached to that name is some unique identifier that you use to place your transaction. Make a telephone call, for example. And if using that example, just like how you would look up my name, Nishal Govardhan, in some, hopefully there was a global address book. We have similar mechanisms for finding information on the internet. Of course, on the internet, things look slightly different, and we have a few different technologies that we're using. So we're going to debunk some of that today, and you'll see the words in bold are the terms that we're going to discuss. So probably starting off with, what is the unique identifier that we use? In the world that you're used to, you know that you have a unique telephone number, for example, +27 for South Africa, followed by something else that follows. Well, in the internet world, we have something called IP addresses. This is a unique identifier that you get assigned either from your internet service provider or a different regional internet registry or something like that when you connect to the internet. And there are two versions of this. IPv4, which has been around since the start of the internet, way back when, so this is over 30 years ago. But as the internet has progressed, as more and more people have come online, you all know the numbers, we have over 2 billion online today, we need to get more and more of these unique identifiers out. And to do that today, we have a new technology called IPv6, and the number is somewhere down there. It's 340 undecillion. That's a lot of zeros. We're not going to discuss that in too much detail. So you have the unique identifier, which was, you have the unique identifier, which was the IP address, the thing that will allow you to connect to some resource on the internet. But you need a mechanism to be able to translate something that you know. How do I translate my name to a telephone number? Well, your brain does that intuitively. But for use in the internet, we have a different tool. The process of getting that in place we call resolution. And it's the process of converting a human-readable domain name to some unique IP address that we will get to on the internet. We do this through a query to a DNS server. A DNS server, a query is basically the same as saying who is or what is, and of course we get a reply back to that. And of course, everything on the internet's got to find a mechanism to move backwards and forwards. And so the jargon that we use, the technical guys, is called a packet. This is the smallest transferable unit of information that can be sent. So all internet communication literally is the exchange of packets. I send a packet as a query to you. Hi, would you like to talk to me? And you send back probably a much larger packet with more information. Yes, I'd like to talk to you. Here's information about what we can discuss. So that's a lot of jargon. Let's look at this from a practical examples perspective. So how does web browsing work, for example? What happens when you open your browser and you type in something like www.icann.org? Well, you've heard some of the jargon. You've heard me talk a little bit about DNS and queries. And here's a new one for you, a URL, or Uniform Resource Locator. And this is effectively a combination of some protocol, some language that needs to happen for communication to happen. And probably the one that most of you are familiar with, the one that drives the web today, is called HTTP. The URL, in turn, sorry, we seem to have a bit of lag here. There we go. The URL, in turn, contains what we call a domain name. And the domain name is really our hint, our clue for where the information we're looking for actually lives on the internet. So so looking at those two elements, we said that there would be something like the protocol that's spoken. And in this case, you can see it says HTTP, or the example here is HTTPS, which is secure HTTP. The domain name part of the example that we're using is www.icann.org. That's the unique part of that's the unique bit on the internet that identifies this. Now, this in turn is quite complex. It's made up of quite a few things. Domain names usually start from the right-hand side in some sort of hierarchical manner, working their way down. So on the right, we have .org. And .org is a generic top-level domain where typically non-profit organizations would have registered their names. The particular non-profit that is part of this .org is called ICANN. We'll talk a bit more about that later on. And the actual machine, the host, the service that you're trying to connect to, in this case, is called www. So there's probably a machine somewhere just called www. So that's if you combine all of that, that gives you the domain name. But that doesn't really help your computer too much. The computer sees this only as one long string. It sees www.icann.org. And while that's great for us, we still need mechanisms to get computers who understand binary to be able to resolve this. Before we move on, it's worth mentioning, talking a little bit about a top-level domain. We've seen that an example of a top-level domain is .org. And that's one type of top-level domain. That's one what we call a GTLD, a generic top-level domain. Other ones that you're probably familiar with are .com, if you've been around for a while, .mil for the US military, for example. But there are also special country code top-level domains. I live in South Africa, and the top-level domain for my country is .za. The top-level domain for Turkey is .tr. And today, there's a new process for getting new top-level domains. Some of you may have been involved in this. You may have heard that there's lots and lots of new names out, like .coffee, for instance, which is something that I'm quite fond of. We also have a large portion of the internet that's not natively English speaking. So it's really in the interest of all of us to be able to get them online. And the mechanism that we use to get non-Latin script characters into the domain name is called IDNs. So Egypt has .mazr, for example, and there's about a dozen others that are out there. Now, in the last example, you saw that we have a mechanism for getting to www.icann.org. We know that we want to get to that. We want to retrieve the information. What's the process that actually happens? How do we get that information pushed to us? Well, let's look at the typical example. We have our computer, and our computer is trying to do this magic DNS transaction. The DNS transaction is the thing that translates www.icann.org to some information that our computer can then use to request the information. So the first part in that process is, in the domain name resolution process, is that our computer has to contact our ISP's recursive DNS resolver. And that's a lot of text for saying it's a server at our ISP that will try to help us in the first step in this process. So it's going to take responsibility for finding out the magic IP address for icann.org. Now, of course, our ISP's DNS server doesn't know everything in the world. So going back into the DNS hierarchy, it's got to have a structure. It's got to have a way to identify how do I do this. And the first thing that it does is it tries to contact the nearest Anycast root DNS server. And these are special devices. There are about 1,200 of them, numbered numbered to about 13. And it asks the DNS root server it asks it for information about www.icann.org. Now, of course, the DNS roots don't know everything either. What they do is that they work on a system of hierarchy. We don't know about www.icann.org, but we do know about .org. So the root servers reply with the IP address for the information for the .org name server. Now, our ISP's DNS server still doesn't have the entire answer, but it is one step closer. So what it does is it then goes to the nearest anycast.org name server, and it says, hi, I'm looking for information about www.icann.org, and you're supposed to be responsible for .org, so I kind of expect that you should be able to tell me at least about icann.org. And that's pretty much what we get back. The Anycast.org name servers responds with information about icann.org. So you can see the chain of delegation has gone from org, and now we're at icann.org. Armed with the information about ICANN's DNS server, we can then query ICANN's DNS server again and say what is the information for www.icann.org, what is the IP address, and because this is where we expect that information to live under the icann.org domain, we should get an answer that says, our DNS server would get an answer that says, this is the IP address for www.icann.org. Now at that point, our DNS server can then pass that information to our host, our smart device or laptop or whatever it is that you want to use. And that's the first part of the transaction, and that's all happening under the hood, unbeknown to you, because all you've done is literally just typed in www.icann.org and hit enter. You now have the IP address, and you're able to contact ICANN's web server. If it's up. There we go. We're now able to contact ICANN's web server, and ICANN's web server will respond with the information. Maybe you're looking for information about policies or anything. So great, we've got the process of finding information in place. But that's only part of the equation. We know whom to ask at this point. But remember, I said at the start that in order to move information on the internet, we put information into packets. So how do the packets move backwards and forwards? Well, ISPs have this, ISPs and the network guys have this technique called routing. And routing is a decision-making process whereby data packets are forwarded through some sort of network, the IP network that we run, the big network of networks that we call the internet. And so we're going to see a routing example to see how this works. So we've simplified a model of the internet for you. Here we have a very simple user on my left, your right, your left as well, sorry. You've got a user on the left trying to get to content on the right-hand side, the server. We have two ISPs, and each ISP is connected to an internet exchange point. An internet exchange point is a place where internet service providers interconnect and exchange information, and we'll talk about that in a second. Now, of course, as I said, this is a simplification. Aside from one user, today we have close to 3 billion users online. From 1 or 2 internet service providers, there are probably over 6,000 internet service providers, and we're using 2 internet exchange points, but in reality, there are about 400 more internet exchange points globally. So how do the packets move backwards and forwards? Well, we know the destination. We have an IP address by virtue of the fact that we're connected to the internet. We have our own unique identifier. That's us. We know whom we need to speak to because we've gone through the process of finding that through DNS. Now we ask our ISP to move this packet backwards and forwards. ISPs move packets in literally one of 2 ways. There's a relationship that they keep with other internet service providers called transit. Transit is a relationship where one internet service provider pays another to carry the first ISP's traffic through their network. So it's really very simple. And that's the base model for how most internet service providers work, at least in my part of the world. But that's not the only model for how internet service providers connect. Sometimes 2 internet service providers agree that it's in their best interests to interconnect their network and change traffic freely with each other. And that's called peering. Typically, peering happens at what we call internet exchange points, a location, usually a neutral location, where lots of internet service providers agree to connect to. And then, in that shared location, they exchange traffic with each other. So we're in the process of trying to make the connection from the eyeballs, the user, through the server. The first thing we do is we send packets, we send a request to our ISP, in this case ISP Red. Now ISP Red is connected with ISP Green at 2 exchanges, and you can see the exchange on the left, Internet Exchange Point West, is close to ISP Red, whereas Internet Exchange Point East is closer to ISP Green. ISP Red has 2 potential ways to get that information into ISP Green. It can go to the exchange point on the left, ISP West, or it can go to the exchange point on the right. But what it aims to do, what ISP Red, and in fact what all ISPs will want to do, is a technique that we call hot potato routing. So imagine holding a hot potato in your hand, and you want to get rid of this as quickly as possible. And in the same way, ISPs make that economic decision to try to get traffic off their network and onto another network as quickly as possible. All right? So in our simple example here, ISP Red has handed across the traffic to the exchange point West, which in turn gets it into ISP Green's network, and ISP Green is able to deliver the traffic to our customer, sorry, to the content on the other side. Now, of course, this is one part of the transaction. This is the simple request. There's got to be a reply. And in the reply, the server sends information back to ISP Green. And ISP Green has the same choice that ISP Red had a short while ago. Should I send my traffic to Exchange Point West, or should I send it to Exchange Point East? And again, using the same methodology, the same idea of hot potato routing, trying to get traffic to the destination as quickly as possible and off my network as quickly as possible. It, in turn, will move traffic to ISP East, where ISP Red is connected. ISP Red will pull this traffic into its network and then, in turn, deliver this to the user. And that's the process for how a simple internet transaction happens. The important thing to note here is that each ISP is involved in half of that transaction. So ISP Red gets a sum of money from the user, and it uses portion of that money, portion of the fee that's paid by the user, to provision its network, obviously its own infrastructure, and connections to the internet exchange point. ISP Green does exactly the same on the other side. So what you have are two internet service providers that are literally splitting the costs of interconnecting almost in half, pretty much in half most of the time, to get the internet transactions happening. And that's what we rely on a daily basis. And that is my time, so I'll hand off to Audrey to finish the rest. Thank you.
Thank you, Nishal. Good morning, everyone. So Nishal has given a bit of a technical overview, and in the next section we're going to talk a bit about governance-related organizations and how they work together. It seems appropriate to start with how Internet protocols get defined. This is by the Internet Engineering Task Force, which you are probably have at least heard of or are very familiar with, depending on your experience so far. The Internet Engineering Task Force is a distributed body of experts around the world who meet 3 times a year. They operate continuously with each other in terms of development of protocols and standards online, virtually, in between the times that they meet. In addition to writing standards and protocols that help define the infrastructure that Nishal just described, they also delegate unique identifiers to the IANA. You've probably heard a bit of talk about the IANA just in the last day of being here, if you've been here that long. The IANA is the Internet Assigned Numbers Authority. And we'll talk about that a little bit more late in a few more slides. But within the IETF, there's 2 bodies that are worth noting if you're not familiar with them. The Internet Engineering Steering Group, which consists of the regional directors of the IETF, and they're responsible for keeping things going within the IETF. They produce a lot of documents. They have a lot of communications. They plan a lot of meetings. There's a lot of work to be done with regard to that. And there's the Internet Architecture Board, which is a body of experts that, with deep technical knowledge, who essentially provide guidance to the IETF, and we'll talk about later how they define and delegate numbering names and numbers to ICANN and the IANA. In addition to IETF-related protocol standards, there's a few other bodies that operate in the sort of non-internet but related protocol space. The IEEE, which you're probably familiar with, they mostly work at layer 1 and layer 2 signaling standards, so things like Ethernet that sit sort of below layer 3 of what we think of as the internet, and above is where you get IEEE standards. And then the W3C, the World Wide Web Consortium, Nishal talked about the www in the domain address. This is at layer 7, so applications and above. And then the ITU works mostly on analog telephone and telephony related standards, that most of which predate the internet per se. Did I go too far? Oh. There's actually what?
So I was going to say it wasn't going backward for me, but
yeah. Got it. Okay. So going back to, and I just one note about the standards and the IETF, the thing, in addition to its uniqueness of being distributed and a very bottoms-up consensus-driven process, is the importance of interoperable hardware, software that makes the internet as vibrant and helpful and necessary as we all know it to be today. That without that without those authoritative standards bodies who work on standardization across protocols and hardware and software, I think it would be we'd have a very different experience on the internet today than we do. So. Global standards, very important, consensus building process across the industry, open to any participation from anybody who would like to attend, is some of the unique characteristics of the IETF. Just moving on to the unique identifiers that Nishal talked about. Unique identifiers are fundamentally necessary for the internet to operate. So the obvious question is, well, who's in charge of keeping that list of unique identifiers? And with regard to the IANA, which is responsible for unique IP addresses and the unique domain names, those operations are defined by the IAB. We just spoke about via IETF RFCs, which are requests for comment standards documents. So there's a hierarchy, as Nishal talked about, starting up with the IETF, and things get delegated down, or names and numbers get delegated down the hierarchy. And from there, once the IANA has their delegation, they delegate it down to resource-specific registries, and then it continues on down to, we'll talk about RARs in a minute, and often to service providers, and eventually an IP address will end up attached to your machine or a server that you're trying to query or something. So in addition to the IANA, there's ICANN, which I'm sure everybody has at least heard of, if not interacted intimately with on some level. The Internet Corporation for Assigned Names and Numbers is the organization that's loosely responsible for coordinating the domain name system of the Internet. It also hosts the IANA function. So the IANA function is a separate entity, well, is an entity within ICANN. IP addresses and autonomous system numbers. I mentioned before that there are 5 regional internet registries. The delegation of unique addresses from the IETF to the IANA then flows down to the NRO, the Number Resource Organization, and from there on to the regional bodies. You can see them listed here. The thing that I think is important to take away from this this slide or this concept is the not only the hierarchy here, but also the global coordination that happens among the 5 RIRs to maintain the unique addressing system that's critical for the internet to continue functioning the way that it does today. And there's a lot of policy issues related to IPv4 addresses and IPv6 addresses and how policies get made within the RIRs, but I think the important thing to know is that they're all community-driven organizations with membership, that people participate in the policy-making process, and they're generally open organizations from a governance perspective. I don't actually know how this build works. This just details out, that was a good one, how the IANA delegates the addressing space down to AFRINIC, APNIC. APNIC is in Asia, ARIN is in United States and Canada, LACNIC is in Latin America, and the RIPE is in Europe, for those who aren't familiar with all the regions. In addition to the RIRs, there is I think a breadth of a very broad technical community across the world, often characterized in terms of network operations groups or NOGs. They're sometimes national in nature, sometimes regional in nature. We've listed a few of them here. I don't know if you know exactly how many there are these days. about 30 around the world. So these are folks that get together multiple times a year to work on operational coordination issues with regard to the internet. There's usually a fair amount of technical knowledge and expertise that sits in these organizations, and so it's always a good place to go to start a discussion on technical or to some degree policy issues within a region or a country. In addition to that, Nishal talked a bit about exchange points and transit and peering. Exchange point operations, many of the regions have regional meetings that work on exchange point related issues. There's one in Latin America, LAC-IX, same in Europe, same in Africa, same in the Asia Pacific. And the other point here, which may not be very clear from the way we wrote that bullet, is the exchange points have membership and meetings that help define their operations and their policies. So also from a governance perspective, open and participatory. Just moving on. Just a few notes about advocacy. There's a lot of advocacy groups here at the IGF, and many that you've probably interacted with. We didn't attempt to make an authoritative list of everything that's out there that's working on advocacy issues. As you look at the agenda for the IGFs, for the last 9 IGFs, the topics have ranged from freedom of expression to security to ICANN-related issues, so it's net neutrality. The topics are very broad, and there's different advocacy groups within those topics. But we thought we'd just highlight a few today. The first is ISOC, the Internet Society, which you've probably at least heard of, if not engaged with. They have local chapters around the world. They're really chartered with outreach and knowledge building. And they're working, mostly representing the end user and the policymaking and regulatory process. So they're very engaged in, IGFs and related internet meetings. Another example of a group, the Open Net Initiative, is a group that works on censorship and transparency issues. They look at what governments are doing in terms of censorship and content filtering and things like that. They publish data. And much of their data are cited in various reports and policymaking endeavors. The last one we thought, we tried to sort of pick organizations that represent a different set of stakeholders. So the last one is the International Chamber of Commerce, which is mostly a business advocacy platform that represents the private sector, and not just companies like Intel or Microsoft or whoever, but a broader set of companies that use the internet as a foundation for their business. And a few notes on, in addition to advocacy, there's a few groups worth noting on operational support. The Packet Clearinghouse, which Bill and Nishal are with, they provide operational support and services for internet exchange points and the domain name system, and I'm sure they'd be happy to talk to anyone here who has questions in that regard. The NSRC, the Network Startup Resource Center, they also provide training materials to people in their communities who are working to connect to the internet. The first on the security side is a Forum for Incident Response Security Teams, is a global coordination group that tries to connect security incident response teams in order to share information better to respond to security incidents on the internet, of which we know there are many. Let's see. Oh, that was the last one.
So yes, this is live. So I'll turn it over to you guys for questions at this point, and we'll try to cover all the many issues that time has been too scarce to throw into the slide deck. We have 22 minutes left. Who will start with one? Pinder.
Hi, I'm Pinder Wong from Hong Kong. You mentioned uniqueness in several aspects, unique IP addresses, unique this, unique that. Why is it important for these identifiers to be unique?
Nishal?
Good morning. Thanks, Pinder. That's a good question. So effectively, think about it this way. How do you achieve uniqueness in the world? If I had to say Pinder, I would expect you to respond. I wouldn't expect anybody else to respond. When you're communicating with somebody, at least across the internet, you want your communication to be one-to-one, right? That's the kind of expectation that we have. I want to talk to you. So I say Pinder, and you say, yes, Nishal, and once we've sort of loosely authenticated with each other, we can then have that communication. So I need a way to identify you across that internet. And then, of course, the way to identify you, maintain your uniqueness, has to have a branch that follows it. There's got to be some sort of loose hierarchy, in the hierarchy that you would have seen Audrey describe, where the numbers come out, well, the IETF gives IANA the authority to delegate the numbers, and the IANA then pushes that across to the RIRs, who then sub-delegate to the individual ISPs or the individual users. You don't want to be in a position where, I mean, how would you complete a transaction if, sorry, it would be extremely difficult to complete a transaction if half of what I was going to say was going to go to you, and then somebody else popped up and pretended to be you, and I would pretend to talk to them as well. So, you know, there's security issues that you can think about there. There's long-term communication problems. So if you want to have a long communication with somebody, say sending an email, that's usually a good few hundred packets. And you can't do that if you're trying to send to multiple people, or you don't know exactly whom you're speaking to. And if you think back, I'm sorry, it's a long answer. If you think back to the model of the internet was really simple. The model of the internet was, as long as you knew whom you wanted to speak to, and that person was able to run a service, then you would be able to connect to them. And then that's an important concept. I think we've lost track of that a little in the way we're running the internet today. But the idea was that if you had a server sitting on the west coast of the United States, and if you knew how to address that, and you had a piece of software, you had code that could run on that server, and you had a client, you had a different piece, something that could request code, and you were in, say, a research center at CERN, you could send information without any knowledge of what was inside. You could send information to that unique address that was expecting to listen, expecting your response, and that could reply to you. And having that open mechanism, that open, unique connectivity mechanism, the open mechanism of the internet, where you don't have to worry about how do I get my data there. All you care about is I'm handing it off to an ISP, and an ISP then becomes responsible for delivering this to me. That's really important, because that's how we develop the internet. If you think about something like the web was an overnight, well, I wouldn't say overnight, it was an over weekend introduction for us. But if you contrast that with some other systems that we have on the internet that don't have this sort of open model for connectivity, we've taken years to get things like DTMF, dialing in my country.
So there, oh yeah, go ahead.
So I think, yes, that I agree with what Nishal said, but perhaps even more simply is the idea that you want to be able to communicate with whether it's a machine or an individual behind a machine, and if the identifiers aren't unique in that regard, you won't necessarily know that you're getting to the place that you want to get to. In addition to that, sort of the value proposition of the internet to a large degree is this sort of global network of information that everybody can take advantage of. And so the uniqueness is really fundamental, because if I go to www.icann.org and I see one set of content, and Pinder is in Hong Kong and goes to www.icann.org and sees a different set of content, then the value that we've sort of created by having this global network to distribute essentially communications and information is broken apart. And the breaking apart is it's not advantageous to consumers, to business, to end users who are looking for data and information.
So I'll just very quickly add that what
we've just been talking about here is unicast. Unicast means I want to talk to one specific other person, and so having a unique address allows me to talk to that specific other person or machine. There's also broadcast. So broadcast is if I yell, hey everybody, there's a fire in here, get out, right? That's a communication from one to everyone. There's also multicast, which is from one to whoever is interested. So it's not necessarily everybody, but anybody who cares about that content can subscribe and receive a copy of the packet. And lastly, there's Anycast, which Nishal mentioned in the context of the domain name system. Anycast is whoever's nearest. Could you pick up that pen I dropped? That's talking to one entity, but not an entity that I know in advance which one is. It's just whoever's nearest of a set of people who are applicable. So move on to the next question. Ma'am.
So the first is just, what is the relationship between the regional internet registries and the ISPs? Sort of like, what are the different roles or accountabilities between them? And then you had mentioned that those 5 RIRs were kind of open, participatory, community-driven entities. And if you could explain a little bit more about what the avenues for participation in those are.
Maybe Nishal should start, because Nishal was the Chief Technology Officer of Afrinic, which is one of the 5 RIRs until quite recently.
Thanks, Bill. Okay, so the first question was, what is the relationship between the regional internet registries and internet service providers? Well, if you sort of remember the chain, they're the unique IP addresses, so the IP addresses are manufactured somewhere. They then need to be distributed, and they get handed out to the different regions. So there are 5 RIRs. There's LACNIC for the Latin American region, ARIN for North America, which is effectively Canada, US, and some islands. The RIPE-NCC, which handles Europe. Afrinic, which does Africa. And APNIC, which does Asia Pacific. So if you think about the total of IP addresses, IANA effectively hands out branches of that to these 5 RIRs, to these internet registries. And from the internet registries, they then have processes. They have their own separate policies and their own separate processes to hand out IP addresses to their membership. Membership of an RIR is usually to people like internet service providers, web hosting companies, pretty much anybody that has to do anything in the internet business in their region. And now each of the RIRs have their own mechanisms and their own unique bits and quirks for membership, but that's what it comes down to. If you operate an internet business in one of these 5 regions, then you will get, or you can get, IP addresses from the RIR that's responsible for your regions. So that relationship, effectively ISP, RIR is sort of retailer, wholesaler, I get addresses from my RIR. The second part of the question was, how do policies work? Did I remember that correctly? Open, right. So the RIRs work in what's called a bottom-up model. Effectively, what happens with the RIRs is they each have their own community. So I'm from South Africa. Obviously, this is part of the African community. And I can tell you a bit about the Afrinic process, which is similar, but potentially slightly different from what may happen in the American region or may happen in the European region. And those slight differences, if at all, only come about because of the scale of the networks in some cases. So in some cases, what will happen is the region itself is responsible for setting rules for how the RIR will operate. One of the simplest rules that the region sets is, what is the smallest block of address space that I should give to an ISP? So as the ISPs, as the web hosting companies in the region, there would have been a policy, there would have been open discussion. All the RIRs have at least 2 meetings every year, and they have active mailing lists. There would have been discussion on these mailing lists, discussion at these meetings to say how much address space, how much unique IPv4 or unique IPv6 address space should I give to one of my members, one of the internet service providers. You know, they developed that idea, and when it was complete, they'd call that a policy. And that policy has to be ratified by the community and, well, whatever other rules that are typically inside the RIR. And then the RIR operates specifically according to those policies. That's a founding basis for how the RIR system operates. So you've got this bottom-up feeding process into this sort of open collaborative policy setting that then drives how the RIRs operate. And as I said, allocation of resources is just one policy.
There's a very important term that we have not defined yet, which you'll hear a lot over the upcoming week, which is multi-stakeholderism. Audrey, could you sort of help define that in this context?
Well, that wasn't what I was going to say, but however, I was just going to answer your question a slightly different way to say that with regard to the ISP's relationships to the RIR, they're normally, it's a membership-driven organization, so they join their regional internet registry as a member. There's usually some nominal dues related to that. And I'm not sure what that is for each region, but it's not just ISPs that are members of the RIRs, as Nishal said. It's also other companies and organizations that have a need to request addressing space from their RIR. Regarding multi-stakeholderism, I think to be a bit provocative, I would say that there is not necessarily one agreed upon definition, but it is generally perhaps understood to mean participation from a variety of what we like to call stakeholder groups. Usually that means people from any viewpoint or any part of the community, whether that be technical folks like Nishal representing, well, now PCH, but formerly an RIR, or an advocacy group like the Open Net Initiative that I mentioned, or there's a whole youth contingent here at the IGF where there's young people participating. Really, it means that essentially anybody could come, but more important, not that just that they could come, but that they have equal sort of power in the conversation, so that there isn't a decision-making authority of one group being more powerful than another in terms of what happens with regard to the discussions. And so that's, I think, generally what people mean by multi-stakeholder.
Yeah, I think that's one of the really important defining characteristics of the internet. Unlike pretty much any other sort of global scale project, in the internet, governance and engineering, everything is done by the people who show up. So the policies by which IP addresses are allocated to internet service providers or to regular companies or to individuals, all of those policies are defined by the people who come to the meeting. You don't have to be a member, you don't have to pay anything, you don't have to represent anybody else. So if you're the government of Tokelau, if you're the government of the United States, if you're just a 15-year-old kid, everyone's voice is equal in that decision-making process and that conversation. Next question. Sir.
Thank you. So how are the IPs allocated to the regional RIRs? Is it like the RIRs request number of IPs? Is it by size of population? How does that actually work?
This gets to the needs basis for IP address allocation, which is something that is sort of under continuous pressure and review, but under more pressure now as IPv4 addresses become very, very scarce. So Europe and the Asia-Pacific region have already run out of unassigned IPv4 addresses. So if you need an IPv4 address and you're in Europe or the Asia-Pacific region, you have to go to the market to try to convince someone to give you some, right? There's also a bit of controversy around for instance, there are several Chinese companies that are trying to establish themselves within the African region in order to be able to get some of the remaining IPv4 addresses from the African region. Obviously, this spurs debate and controversy within the African policymaking community about under what terms, if any, should that be allowable. Yeah, so historically, with IPv4 and continuing with IPv6, IP addresses are just numbers, right? They're just integers. So in theory, there would be kind of an infinite number of them. But in fact, the packets have a limited amount of space in them. So there's only enough room for a number of a certain size. So with IPv4 addresses, there are only about 4 billion, 4.3 billion addresses. Sounds like a lot, but that's fewer than 2 per person right now. And how many IP addresses are you using right at this moment? There's at least one on your telephone. There might be another on your laptop. You might have a web server somewhere. You might have an email server somewhere. That's 4, right? And it adds up. So, so there isn't enough IPv4 space. We knew in 1996 that this would be a problem, and we began this process of introducing IPv6, which has a much larger address space, enough address space that it's sort of inconceivable to us now, as it was inconceivable to us in 1996 that we would run out of this larger space. So big chunks of equal size are delegated from the IANA to the regional internet registries in response to a request from the regional internet registries. That, in turn, is driven by the needs of their constituents within the region. So the reason why Asia and Europe ran out first is because when the IANA ran out of new IPv4 space, Europe and Asia were using space at the fastest rate. And because it always gets allocated in the same size chunks from the IANA to the RIRs, those two ran out of their last chunk first. Whereas LACNIC and AFRINIC both have several years run rate at current utilization, and ARIN in the Americas is going to run out sometime this year, probably. Is that pretty good? Yeah, okay. Sir, next question.
Yes. My name is Eduardo Bertoni. I'm from Argentina. Maybe it's a follow-up question. I'm talking on IPv4, but I think that for IPv6 might be the same. Very simple question. I connect to the internet with my computer now. The server provider is going to give me an IPv4, yes? So that means that my computer might have different IPv4 depending on the server provider that I connect, correct? This is exactly the same for the IPv6, or for the IPv6 it will be possible that I will carry always the same IP number, IP address?
So the short answer is it will be exactly the same in IPv6 as it is in IPv4. The slightly longer answer is you're saying, well, I always get a different IP address depending on what internet service provider I connect to. But if you were an internet service provider, you would be taking your address space with you, because you would have something called an autonomous system. An autonomous system is a network that has IP addresses that it uses that can be advertised throughout the internet, right? You can connect to anyone you want to and tell them about your addresses, and they will believe you that those belong to you. Now, there are different ways of checking to see whether the address actually belongs to someone. If you're an end user and you get an IP address from your internet service provider, there isn't much worry about trust here, right? I mean, they're going to give you an address, and either it'll work or it doesn't, right? It's not a question of you getting a fake address or something. But if you're trying to build the whole global internet, the issue of whether someone is asserting that an address belongs to them when it doesn't, that might be due to fraud, or it might be them trying to get in the middle of like a banking transaction, or get in the middle of someone else's email to see what's in the email. There are a lot of different reasons someone might fraudulently advertise an IP address. So there's a whole area of work being done in the IETF on securing BGP, Border Gateway Protocol, which is the routing protocol that internet service providers, anyone with an autonomous system number, an autonomous system, uses to tell each other about how to get to different places on the internet. Because if we're here in Turkey and we want to get a packet to Rome and someone says, here, the shortest path is through Tokyo, we don't want to believe that, right? We want to believe that the shortest path from Turkey to Rome is going to be sort of around the Northeast Mediterranean somehow. Either of you want to add to that at all? Okay. Oh, yeah, remote, sorry.
A question from online, Ayori Selassie. How do we balance the influence of commercial organizations that support the internet with the needs of its global users? And there's a second part, second question. Who pays the bill for all these different organizations, the RIRs, ICANN, etc.?
Audrey, you want to take that?
Bevel, could you just say the first part of the first question again? I just didn't understand.
How do we balance the influence of commercial organizations that support the internet with the needs of its global users?
So I think I would say the short answer to that is the multi-stakeholder model that we talked about earlier, and through organizations and opportunities like the IGF. I think it is a challenge when you get to some of the different governance organizations because there are different interests that are represented there depending on what the policy issues being discussed. So and there's a lot of meetings to go to every year, and not everybody has infinite time and resources to devote to them. So I think that's a big challenge. It's one that has been on the top, discussed starting at least for several years now, but certainly last year in Bali when there was an introduction of some new initiatives coming down to say, well, how many more things can we really support? On the flip side of that, I would say that in terms of balancing the interests, the question was who pays for all these organizations, and there may be people may have some better answers in the room, so others should chime in. But to some degree, it depends on who you're talking about. So like this meeting is paid for by the Turkish government and some contributions from industry in different capacities. There's been an effort to establish a trust fund for the IGF to provide more financial stability for it. That's just one example. With regard to an organization like ICANN, revenue is generated from domain name registrations and contracts with the contracted parties. The RIRs, there are, as I mentioned, membership dues that come from the constituent members. So, there's some amount of variance in terms of how the bills get paid. With regard to ICANN and the new GTLD process, that's been well publicized in terms of the cost associated with that. So I don't know, Bevel, if there's a more specific question about an organization, but yes, Steve.
So I would just comment back to the other person that essentially industry pays for the RIRs. In other words, it is not governmental, it's not citizens, it's businesses who essentially pay for those directly. One of the issues that I am struggling with as a lawyer is to translate the lecture that you gave this morning to judges in different countries. And I'd welcome any colleagues who are here who are lawyers and have had the opportunity to try and explain this to a judge in their country, how you do that. I have certain ideas about how to do that, and I wanted to share them with you. Thanks.
Can I follow up with that, because that's a very good point. I'm also particularly interested in law enforcement, so even before getting to the lawyers and the judges, how does law enforcement work in the context that you've explained? For example, IP addresses. How do you work with law enforcement agencies?
Let me really quickly just note that we are over time at this point, and I'm going to put up our email addresses in case anybody wants to follow up with any question that didn't get asked yet or that there hasn't been time for before we go on to talking about law enforcement cooperation. Either of you guys want to start out on that?
No? Okay. I'm sorry. So the question was, how does law enforcement work with IP addresses? Well, at its most simplest form, what a regional internet registry does is registration of the resource that has been allocated. So when an ISP comes to a regional internet registry and says, hello, we'd like to get, we can show need for, and we'd like to get a block of IP addresses, say 1,000 IP addresses, which is a relatively small size. What the regional internet registry does is it registers these in a system called WHOIS. That's the Internet Telephone Directory Service. And that's how that works. And WHOIS is the definitive source for where and how these IP addresses should be used. So in the sense of something illegal happening, the RIRs don't actually have control of any of that. Obviously, it's whoever is using the resource that may or may not be doing something illegal. But what the RIRs have is the registration information for who would have or who has the right to use that resource. Now, sometimes that resource right is abused, and Bill mentioned some of that, and he mentioned some work that's being done, particularly with the RIRs, to try to enforce that and to make sure that there's less badness, so to speak, that happens on the internet. But
and I think with regard to WHOIS specifically, there's constantly a discussion and a little bit of a battle between privacy issues regarding, the amount of information one has to give into the WHOIS directory, and the legitimate needs of law enforcement, of which there is, a fair amount of debate around these days. And so I think that's just something to note. There's the WHOIS exists, and there is some tension around how much information one has to give when one registers either a domain name or when your IP address allocation is noted. Less of an issue for corporations per se, more of an issue for individuals, but it's certainly, you may hear about that, it's certainly a big issue of ongoing controversy.
Yeah, last year's IGF in Bali was held right after the Snowden disclosures, so the majority of the questions last year were about security and intelligence and interception and so forth. With that, I thank you all very much. Nishal and I have to rush off to a session that begins in 7 or 8 minutes. Again, please just catch any of us in the hallways or email us if you have any questions that we haven't answered, or if things come up over the course of the week that we can help you understand or give you background on. Thank you very, very much for your time and attention.